This is geotrig lesson 17. This is day 2. And what we're going to basically do is just do proof number 2 of the Pythagorean theorem. So a squared plus b squared equals c squared. So this is what I propose. I propose that we take a triangle and we call it a right triangle with sides A, B, and C. You guys would be like, oh, I can use the Pythagorean theorem on that. A squared plus b squared equals c squared. Yeah? Well, here's the thing. What we're going to do is I'm going to take that, copy it 3 more times. So I would assume everybody would understand that if I took the area of said triangles, each one of them would be 1/2 a times b. 1/2 base a times b, which is the height. You guys okay with that? Okay. So area of a triangle is 1/2 base times height, where the base is a, the height is b. So if I was to combine all 4 of those triangles together, it's just 4 times 1/2 AB to get 2AB. Is everybody okay with that? Okay. Now, this is where things are going to get really interesting. On the next slide, it's going to be full of stuff. I'm just going to talk about it. The next slide, what I'm going to do is I am going to take these 4 triangles and I am going to arrange them to form a large square. Take a look. Boom. I put end for end, leaving 90 degrees on the outside. Notice that each side is made up of a b plus a or an a plus b. Can you guys see that? Notice it forms a large square. The triangles that are white here are the copies in the original from the other slide. We have a side A, we have a side B, and a side or hypotenuse C. Okay? Would you guys agree that since they're exact copies of each other, they are congruent? Those triangles from this last page.
Yes.
These 4 things are congruent.
Yes.
Okay? They're just copies. Okay. So therefore, what we were saying is that EF, where's EF? EF, which is E to F, F to G, G to H, and H back to E are all congruent. They're all the same. They're all C values, right? And if they're all C, they're all equal, we call that equilateral. The last time you probably seen the word equilateral was an equilateral triangle. And that meant all the sides are the same. It applies to more than just triangles. A square is equilateral. All sides are the same. Okay? So, I'm thinking most of us can understand that. We can get that just by looking at this. All the sides of this inside piece are the same. So you're thinking, well, that means that this thing inside has to be a square. Does it really? Isn't a, don't want to say a rhombus? Doesn't that have all 4 sides the same, but it's kind of pushed over just a little bit?
Yes.
That's not right angles. So now, the next process, starting here, is we're going to show that we do have right angles. Wait a minute. Angles 3 and angle 4 are complementary. What does that mean? They add up to 90. Oh, it's right here. Angle 3 plus angle 4 is equal to 90. Wait, here's 3. Here's angle 4. And it only makes sense that they have to equal 90 because it's a 90-degree triangle. That means if there's 90 degrees taken up out of the 180, what's left? 90's left between the 2. We also should realize that because we said all of these triangles are congruent, that they have angles that are the same, or, what better word? Correspond with each other. Hence, we say angle 1 and angle 4 correspond with each other. They're equal, right? And if that's the case, if 1 and 4 add up to 90, then can't I replace that to say that 3 and 1 add up to 90? Wouldn't that make sense? And 1, 2, and 3 form a straight line, so they should add up to 180. But if 1 and 3 add up to 90, that means 2 has to equal 90. I'm going to pause it, make sure we're all there. So as you can read then, if angle 2 itself is 90, that means angle E by the same process, F and G, are all 90. We can also say that it's more than just equilateral, it's also equal angular. Equal angular means all the angles are the same. And if something's equilateral, angular, and it has 4 sides, it has to be a square. So that means this thing is a square. How do you find the area of that thing? Length times width, which is c times c, which is c squared. Interesting. Would you guys agree that since every side of the larger square is a plus b, the area of that would be a plus b squared? Yes, yes, yes? But I don't want potentially the area of the non-shaded. I want the area of the shaded. So if I took the area of the big square, could I remove something from there? Like all of the white triangles away from it? What happens if I take away all the white triangles from it? What was all that? White triangle. What was that value?
Oh, 180.
Let's go back up here. What was the value of all 4 of those triangles? Sorry, 4 triangles. What was the area of those 4 triangles?
1/2 AB.
No, it's 2AB for all 4 of them. So if I go here and subtract 2AB, I will then equal c squared. Because the shaded region itself is made up of the large thing. Take away the triangles. So there it is. That's a squared plus b squared equals c squared right here. Do you guys see it or no?
Yep. Wait, so
How does that equal? How many of you guys right now think that's just a squared plus b squared? Done.
No.
That's a rookie mistake, guys. That's not a squared plus b squared. You need to FOIL that.
Oh, yes, so it'll be 2a
Yes.
squared, right?
So a plus b, guys, times a plus b minus 2a will equal 2ab will equal c squared.
Yes.
Whoops, I forgot my parentheses. So it's a times a.
Yeah.
A squared. What's a times b? Plus ab. What's b times a?
AB.
Plus an ab. Plus b times b.
B squared.
And minus the 2ab. Does it equal c squared?
Yeah, a squared plus b.
ab plus an ab is equal to?
2ab.
So the 2ab's will cancel with the negative 2ab to get?
A squared plus b squared
Equals c squared.
Ah.
Now, guys, I'm not requiring you guys to remember this whole process, but you guys have enough information that you guys should have been able to follow that. This is why you need to know the things you do. Is because somebody else sat down and proved that it was true. So you don't have to necessarily. But if you want to obviously know why something works, you got to prove it for all numbers. Notice that we did not use numbers and the numbers in the sense of all value for A, B, and C. We let A, B, and C be any real number. It works.